Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in lecture number 8, paper number IC-10, unit 3. In last lectures, we complete the thermal application of solar energy in field of water heating and space heating and power generation. Now in this lecture we studying about space cooling and refrigeration and one more thermal application, distillation. So we start with space cooling and refrigeration system. See the figure. This figure shows the schematic diagram of space cooling and refrigeration system. Basic information of this application is here is one cycle for solar radiation absorption. Second cycle is for heat transfer and third cycle is for space cooling. So this is the system for space cooling and refrigeration system. We discuss about detail of this system. One of the best interesting thermal application of solar energy is for the purpose of cooling, space cooling and refrigeration. Space cooling may be done with the objective of providing comfortable living conditions or of keeping a food product cold. Here see the diagram. A diagram is a simple solar operated absorption refrigeration system is shown in the figure. Water heated in a flat plate collector. We discuss it about in flat plate collector. Flat plate collector is for heating of water. So water heated in a flat plate collector. Sometimes more than one flat plate collector is arranged. So we call it as array. Water heated in a flat plate collector or array is passed through a heat exchanger, coal generator. So coal generator, where it transfer heat to a solution mixture of absorbent and refrigerant, which is rich in refrigerant. Refrigerant vapor is boiled off at a high pressure and goes to the condenser, where it is condensed into a high pressure liquid. The high pressure liquid is throttled to a low pressure with the help of expansion valve. Please see the expansion valve in diagram. So high pressure liquid is throttled to a low pressure with the help of expansion valve, and temperature in an expansion valve and passes through the evaporator coil. Then after it passes through the evaporator coil. Here that means evaporator. The evaporator, the refrigerant vapor absorb heat and cooling is therefore obtained in the space surrounding this coil. The refrigerant vapor is now absorbed into a solution mixture with drain from the generator, which is work in refrigerant concentration. This yield rich solution which is pumped back to the generator, thereby completing the cycle. So here complete the cycle by this generator and refrigerant. This yield a rich solution which is pumped back to generator, thereby completing the cycle. The rich solution flowing from the absorber to the generator is usually heated in a heat exchanger by the weak solution with drain from the generator, which helps to improve the performance of the cycle. The efficiency at the last, the efficiency of such system is about 50%. This is the schematic diagram and this is complete process for space cooling and refrigeration system. With the help of solar energy at our target point or our place is cool or cooling by some refrigerants. We see some other arrangement for space cooling and refrigerant. This is also a space cooling and refrigerant systems. Sometimes this type of arrangement is also provided for space cooling and refrigerant system. Here complete the solar thermal application for space cooling and refrigeration system. I have some videos for this type of application, so it is attached with here. Please see the videos. Now next application or last application for this lecture is distillation. Thermal application of solar energy for distillation. We well known about distillation. So with the help of solar energy, water is boiled and we get distilled water at our required place. So this is very important thermal application of solar energy. Please see the diagram for water distillation. The principle of solar distillation is simple and can be explained with reference to figure in which a conventional basin type solar steel is shown. Please see the figure. The steel consists of a shallow airtight basin lined with a black impure material which contains the saline water. We show also saline water in figure, and please note that it is very important that basin lined with black impure materials and also it is airtight, so yield of distillation is increased. A sloping transparent cover, we describe it in figure. A sloping transparent cover is provided at the top. Solar radiation is transmitted through cover and is absorbed in the black lining. When solar radiation is starting the heating. It has heat up the water by about 10 to 20 degrees Celsius. Please note that temperature. Solar radiation heat up water to about 10 to 20 degrees Celsius and cause it to evaporate. So evaporation will be started to gain by this 10 to 20 degrees Celsius. The vapor rise, condense as pure water on the underside of the cover and flows into condensate collection chamber on the side. We also describe the water collection thought, where distillate or a distilled water is collected. An output of about 3 liters per meter square. That means if our instrument is 1 by 1 meter, then output is 3 liter with an associated efficiency of 30 to 35% can be obtained in well-designed steel on a good sunny days. So this is the very important application for water distillation. I have some videos for this type of distillation which is attached here. Please enjoy the video. Some of also arrangement for this type of distillation we also see. See the next figure. Their type of distillation process is also used for the continuous process. In this type of distillation process, sea water or a salty water is input and fresh water we get at a normal rate. This is also a one type of distillation still which is also give the very good efficiency with 25% of the distillation. This is also a one type of thermal application by water distillation. Solar air conditioning system. This is flat plate collector where water is heated and it is stored in hot water storage tank. And this hot water is used in heat exchanger where refrigerant or coolant type materials are heated. This is heat exchanger. And this is desiccant wheel where heat exchange by water to refrigerant. And this cold dry air is supplied to our required place. Solar cooling system. This is flat plate collector, heat exchanger. There is one cycle where heated water is passed into heat exchanger where it is exchange heat, and then arrangement of turbine, compressor, condenser, pump, expansion valve, evaporators, and our space where cooling is required. When solar radiation takes place or flat plate collector absorbs the radiation, then it heats the water. This heated water is passed through heat exchanger. This is one cycle. Now second cycle, freon vapors, that is refrigerants, which are heated in heat exchanger and then it passes through turbine, condenser, and that is the refrigerant cycle. Therefore, turbine is converted in mechanical energy. Solar distillation. Feed water in a rectangular type basin. All a day when sun passes, it heats the water. Water evaporated and distillate at inside the top. This is also a solar distillation process. This process is known as passive method. Water is heated in flat plate collector all a day, and this heated water is passed into basin where it heat up and boils the water. So evaporation takes place and water vapor is condensed. Thank you.